Lesson 8-9, Graphing Inequalities, and in this lesson you learn to graph linear inequalities. Why is it important? Because graphing inequalities can help your theater group determine how many tickets must be sold to cover expenses. Okay, and let's take a look at this hands-on activity. The graph of y equals x plus 2 is shown at the right, so we learn how to graph equations, and this is the graph of y equals x plus 2. Okay, remember in the y equals mx plus b, okay, your slope is 1 and your y-intercept is 2, and that's your y-intercept, and you have a slope of 1, meaning your rise is 1 and your run is 1. Okay, so copy the axes on and the graph on a piece of paper, so you can copy this down. Let's figure out how to do this. Graph the following ordered pairs in your coordinate system, and let's look at this one. Let's graph first 3, 4. Okay, 3, 4 is right here, 3 and 4. Okay, and then we need to graph 3, negative 2, 3, negative 2 right here, and negative 2, negative 1, negative 2, negative 1, negative 1, 0. Okay, 4, 4. 1, 2, 3, 4, 1, 2, 3, 4, right there, and 0, negative 3, 0, negative 3, right here. Okay, so where do these points lie in the planar region to the graph of y equals x plus 1? Okay, sorry, 0, negative 3 should be here. My bad, 1, 2, 3, right there. So let me erase that, and let's answer the first question. Okay, first question is, where do these points lie in the plane in the relation to the graph? Okay, we know that they all lie below the line. So which sentence, y equals x plus 2, x greater than x plus 2, or y less than x plus 2 is 3 for all the ordered pairs that you graph. So we want to try this out. These are our ordered pairs, and if you represent the first number of unordered pairs at x and the second number is y, okay, we need to find out if we substitute these numbers, okay, which will make these numbers which will make these sentences true using these ordered pairs. Is it going to be y equals x plus 2, y greater than x plus 2, or y less than x plus 2? Okay, so if we substitute them one by one, we know right away it's not going to be this one. Okay, because if you have y equals x plus 2, if you notice, if you substitute x to 3 to x and 4 to y, this will become 4 equals 3 plus 2, and 4, of course, not equal to 5. So that is already out of the question. Okay, so let's take a look at y is greater than x plus 2. Again, we're using only the point 3, 4. Okay, because one point will determine, okay, if all of these will make the inequality or equation true. So let's use y greater than x plus 2. So if y greater than x plus 2, and if x is 3 and y is 4, so the question is 4 greater than 3 plus 2? Okay, and if you notice, 4 greater than 3 plus 5 is not true, but that's false, so this will not make it true. If you use the last inequality, which is y less than x plus 2, and we substitute the point or the coordinate 3, 4, so y less than x plus 2, and this is 3 and this is 4, and if you notice, will that make our inequality true? 4 is less than 5. Yes, it will make our inequality true. So therefore, if we substitute all these points, okay, this will make our inequality true. So after doing that, we know that in letter B, y less than x plus 2 will be the one, okay, will be the inequality wherein all these coordinates will make this inequality true. Okay, so which sentence is true, okay, for all the points located above the graph of y equals x plus 2? So if these points make this inequality true, y less than x plus 2, the sentence that will make okay the sentence which will make this letter C, okay, agreeable to us would be y greater than x plus 2, because everything on top of the graph of y equals x plus 2 will make the inequality false for y less than x plus 2. Okay, let's recap that. It's simply saying that all these points represent the inequality y less than x plus 2. Okay, and all the points above this line will represent the inequality y greater than x plus 2. Okay, so how many points belong to the graph of y less than x plus 2? And if you notice, if I simply pick any point on that part of our graph, everything will make it true. So how many is that? That will be an infinite number. Okay, so let's learn the concept of inequalities. To draw in the graph of an equality such as y greater than 2x minus 3, first draw the graph of y equals 2x minus 3. This graph is a line that separates the coordinate plane to two regions, two half planes. Okay, so in the graph at the right, so we're not doing the graph at the right, we're doing the graph at the bottom. So we want to graph y is equal to 2x minus 3. So this is the boundary. We want to graph the inequality y greater than 2x minus 3. But before we graph that, we need to be able to graph y equals 2x minus 3. So y equals 2x minus 3. So how do we do that? Again, we first use the y equals mx plus b to be able to graph this. And in this case, our slope is 2 and our y-intercept is negative 3. So let's find our y-intercept, which is negative 3. 1, 2, 3. This is our y-intercept. After graphing our y-intercept, let's use our slope to be able to find the other point. So our slope is 2, or the same as 2 over 1. So if the slope is 2 over 1, that means our rise is 2 and our run is 1. So that means we rise 2 units up and we run 1 unit to the left. Okay? And we simply connect the points after that. Okay? So connecting those 2 points, right there. Okay? Well, you know what? Let's do this. Okay? Connecting those 2 points. Now that now becomes the graph of y equals 2x minus 3. But I'll take it one step further. I'll make it a dashed line, and I'll tell you why later. Okay? So that's the graph of our boundary, y equals 2x minus 3. So that's the first step. Okay? This graph separates the line, the coordinate plane, into two regions, two half planes. So in the graph, one of the regions is shaded yellow. Okay? And the other one is shaded blue. Okay? So in our graph, we shade this yellow right here. Okay, this whole side is shaded yellow. Okay, right there. And this whole side is shaded blue, right there. Okay, the line is the boundary of the two regions. Basically what it's saying is that the equation that we created, okay, this y equals 2x minus 3, or that dashed line, is the boundary of the two regions. To determine which region is the solution for y greater than 2x minus 3, we need to test the point in the blue region. For example, we test the point of the origin. So if we test the origin, remember what our origin is. The origin is the ordered pair 0, 0. Okay, and if we test it to our inequality of y greater than 2x minus 3, where y is 0 and x is 0, we find out that the sentence is true. Okay, so since 0 is greater than 3, it is true. The solution is y is greater than, the solution of the ordered pair 0, 0 is a solution to y greater than 2x minus 3, which simply means one thing. Now, if this point makes the inequality true, all the points in this region will make the inequality true. And that's the reason why the shaded blue part of this graph will make our inequality true. Okay? And if you also notice, if you get a point to the right of our half plane, let's say if we get this point right here, this point is 3, 1, 3, negative 1, I'm sorry. And if we substitute that point to y greater than 2x minus 3, you'll find out that this will make this point will make this inequality false. Let's try it out. So our y is negative 1, and we want to find out if negative 1 is greater than 2 times 3 minus 3. And you find out that negative 1, okay, will be 6 minus 3. Negative 1 greater than 0, this statement will be false. So anything to the right of my half plane at this point will make the inequality false. Anything to the left will make the inequality true. All the points to the left of the half plane will make the inequality true. All the points of the right of the half plane will make the inequality false. Now again, go back. Why is this a dashed line, not a solid line? Okay, it is a dashed line because all the points that lie on the line is not included in the solution. Okay, so all the points that lie on that line is not included in the solution because it's greater than. So one tip that I can share with you is this: if it's greater than or less than, your boundary will be a dashed line. If it's greater than or equal to or less than or equal to, your boundary will be a solid line. Okay? And let's go on to the next example, or the next concept that we need to learn. Now consider the graph of y less than or equal to 2x minus 3. Okay, again, we graph the boundary. This is the boundary, and if you notice, it's a solid line because your inequality is a less than or equal to. So the origin 0, 0 is not part of the graph of y less than or equal to 2x minus 3, since 0 is less than or equal to 3. What it's saying is if you test the point of the origin 0, 0, and you substitute that point to our inequality, it will make our inequality false. So that means anything on the blue region will make the inequality false. So since the inequality y less than or equal to 2x minus 3 means that means y less than 2x minus 3 or y equal to 2x minus 3, points in this boundary are part of the solution. So that's what it's saying. When you have less than or equal to, all the points on that line will be part of the solution. Okay? If it's just less than, all the points on that line will not be part of the solution. And the reason why this is a solid line is because it's a less than or equal to, meaning that all the points on that line will still be part of the solution. Okay? So that's the graph, is all the points in the yellow region, okay, and the line y equals 2x equals 3. So in this particular case, the solution will be this part of our half plane. Everything that's shaded in yellow. Okay? So let's take a look at example number 1. Let's graph y less than negative 2x plus 2. Okay, so let's graph y equal less than 2x plus 2. First and foremost, okay, we need to find our boundary. Okay, our boundary for this graph is y. Okay, y is equal to negative 2x plus 2. Okay, and we know that it's a less than sign, so this is a dashed line. Our boundary will be dashed because it's all the solutions, all the points on that line will not be part of our solution. So if we graph that, this is what's going to come out right here. Okay, so a dashed line where you have y-intercept is 2. That's why we graphed it first. And then our slope is negative 2 over 1, or 2 units down, 1 unit to the right. 2 units down, 1 unit to the right, and this is your next point. And we simply connected the 2 points. Then what happened was that we tested a point. In this case, we tested 0, 0. Now you can test any point you want on any part or any half of any part of the half plane. You can test 1, 1, you can test 2, 2, any point would do. 0, 0 is the best choice because it's easy to solve. So if we test the point 0, 0, you notice that it will make our inequality true. And once that happens, okay, we shade the left part of our half plane. And this is exactly what we did. Okay, so the graph is all the points in the region below the boundary, and we shade that region. Okay, let's do one more example. Example number 2. Tickets for West Side Story are $66.50 for floor and $47.50 for balcony. In order to cover expenses for the show, at least $66,500 per show must be made from ticket sales. Write an inequality to represent the situation. So again, in this case, since it's a word problem, we use a let statement. So in this case, we let X represent the number of $47.50 tickets sold, and let Y represent the number of $66.50 tickets sold. So the sales of $47.50 tickets sold is represented by 47.5x. And then we add the sales of $66.50 tickets, okay, which is 66.5y, okay. It says there at least. So when you say at least, it should be greater than or equal to, and the amount is, okay, 66,500. So that's our inequality. And letter B, use a graph to determine how many of each type of ticket must be sold to cover the expenses. Again, we first need to solve for y to be able to find our slope and our y-intercept. So if we solve for y using that inequality, we now have 66.5y greater than or equal to 66,500 minus 47.5x by subtracting 47.5x from each side. Okay, and from there we divide both sides by 66.5, end up with y greater than or equal to 1,000 minus 5/7 x. Or if you want to put it in y equals mx plus b, okay, we can also write as y is greater than or equal to negative 5/7 x plus 1,000. Okay, so from there, okay, we can graph it, and our y-intercept is 1,000. Okay, so we graph y equals 1,000 minus 5/7 x as solid lines, is the boundary, is part of the graph. Okay, and if you notice, it's only in one quadrant, because when you talk about money, okay, you cannot have a negative money, so we only deal with quadrant 1. It's a solid line, okay, because we're talking about greater than or equal to. And then we started testing a point, so we tested the point 0, 0. When we tested the point 0, 0 for this particular inequality, okay, we found that 0, 0 will make the inequality false. So logically, if the left side of the half plane makes the inequality false, the right side of our boundary, or the right side of our half plane, will make our inequality true. And that's the reason why we shade the right side. Okay? So the graph is all the points in the region that do not contain the origin, which is basically the right side. Okay? And in letter C, it's asking list 3 possible solutions. So basically all you need to do is find any point on this side of our half plane, okay, and that will make your that is a solution of our inequality. So we have 3 solutions that we found, 500 and 700, because when we substituted these two values, it's on the right side of our half plane. That makes our inequality true. We also found 420 and 700, and 400 and 800 are also possible solutions. The secret word for this lesson is Elmo, and that is the end of our lesson. Thank you for watching.